Okay, Wildcats, today we're going to journal page 54, rational function transformations. F of x equals negative a divided by parentheses negative bx minus h plus k. When the negative is in front of the a, it reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative in front of the b inside the parentheses, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's minus k, it translates down. And then asymptotes, it has a vertical asymptote at x equals h and a horizontal asymptote at y equals k. If you would, update your notes. Now your notes are updated. Let's take a look at the examples. All right, rational function transformations on page 54. Graph rational function transformations. Now, before we graph the transformations, let's graph the parent function of rational functions. Okay. Now, let's use 3 points to find points to graph. Let's use -1, 0, and 1. Okay. So you have f of x equals 1 divided by x. So you have f of -1 equals 1 divided by -1, which equals -1. Okay, so you have a point at -1, -1. Okay, now f of 0 is 1 divided by 0, which is undefined. Okay, that means you have an asymptote at x equals 0. All right, now when x is 1, that's f of 1 equals 1 divided by 1, which equals 1. Okay, so you have a point at 1, 1. All right, now with going back to our notes, we see that that's our h value of a vertex, okay? And we know that our k value in this case is 0, so vertex is 0, 0. So you have a horizontal asymptote at y equals 0, okay? So you also have a horizontal asymptote at y equals 0. Now to graph this, basically, once you have your point between the asymptotes, you know your curve lies between the asymptotes. Okay, same thing here. So we know the curve lies between the asymptotes. Okay, now domain would be -infinity to 0, not including 0 because there's an asymptote there, or 0 to infinity. Okay, now the range would be from -infinity to 0 because you have an asymptote there. So -infinity to 0, not including 0, or 0 to infinity. Now your asymptotes are x equals 0 and y equals 0. All right. Now to find the x-intercept, that's when f of x is equal to 0. Okay. So we plug 0 into our equation and solve for x. So 0 equals 1 divided by x. Now we need to divide both this side by 1 so we can cross multiply. So 0 times x is 0. 1 times 1 is 1. 0 will never equal 1. And there is no x, so we would say that there are none. There are no x-intercepts. Okay? All right, now for the y-intercept, that's when x equals 0. So we substitute 0 in for x. So y equals 1 divided by 0. And we know from our table that any number divided by 0 is undefined. So we would say that there are no y-intercepts or none. Okay, now let's take a look at we'll finish up example 1. All right, now let's take a look at example 2. Okay, now we're going to use, and just a hair, we're going to use these points as our directions for our transformation. Okay, but we first need to move the vertex. Now, we see here that that -2 moves the vertex to the right 2. Okay, so we were here 1, 2, and I'm just going to put a small v there, okay, because we're not going to have a point there, and I'll explain why in a second. Okay, now, so our directions, and I need to change this line, put that line in the wrong place. Much better. All right, so we know our directions are -1, -1, 0, undefined, and 1, 1. Okay, well, really, we're not going to use the 0 undefined. Okay, we're just going to use this and this. Okay, but here, this tells us we have to multiply by -1. Okay, so times -1 equals 1, times -1 equals -1. Okay, so from this vertex, we move left 1, up 1. Okay, and then from this vertex, we move right 1, down 1. Now, to understand where our asymptotes are, we need to set x minus 2 equal to 0. Okay, so then x equals 2. There's one of our vertex or asymptotes. So x equals 1, 2. Okay, and since this graph didn't move up or down, we know that our horizontal asymptote is at y equals 0. Okay. Now, once we have our points graphed and our asymptotes graphed, we know that our curve lies between these two asymptotes because that's where the point is. And we know our curve lies between these two asymptotes because that's where our point is. Okay, so domain is from -infinity to 2 or 2 to infinity. And our range is negative infinity to 0 or 0 to infinity. Okay. Now our transformations, we have two of them. The first one is reflex x-axis and to the right 2 units. Okay. Now our x-intercept is when f of x equals 0. So we have 0 equals negative 1 divided by x minus 2. Divide that by 1. So we cross multiply and solve. So 0 times this is 0. 1 times negative 1 is negative 1. Those not equal, so we would say that there are no x-intercepts, or none. Okay. Now for the y-intercept, that's when x equals 0. So then that's y equals negative 1 divided by 0 minus 2, which equals negative 1 divided by negative 2 is 1 divided by 2. So your y-intercept, let me fix these lines up, is 0, 1 divided by 2. While I'm at that, let me fix that. Well, that's terribly messy work. I apologize for that. Here, go ahead and finish up example 2. All right, let's take a look at example 3. Okay, now we know we're going to graph by direction, which we know is negative 1, negative 1, 1, 1. Okay, but before we do that, we need to move the vertex. Now this moves left 1, down 3. So left 1, down 1, 2, 3. I'm just going to put a little V there. Okay, because there's not a point, but that's where our vertex is going to be. Okay. Now, we know here that we have to multiply by 2. So negative 1 times 2 is negative 2, and 1 times 2 is 2. So from here, we go left 1, down 2, and from here, we go right 1, up 1, 2. Okay. Now, our asymptotes, we set x plus 1 equal to 0. Subtract 1, so our asymptote is x equals negative 1. Okay. And then our horizontal asymptote is at y equals negative 3. So negative 1, 2, 3. Okay, once we have the asymptotes graphed, we draw our curve. Okay. Domain and range. So add a line there. Domain, and let's go ahead and add a line for our range. All right, so domain would be from negative infinity to negative 1 or negative 1 to infinity. And our range would be from negative infinity to negative 3 or negative 3 to infinity. All right, transformations. Looks like we have 1, 2, 3. So we have a vertical stretch of 2. That's left 1 unit. And down 3 units. Okay. Now for the x-intercept, that's when f of x equals 0. So that's 0 equals 2 divided by x plus 1 minus 3. So you're going to subtract 3 from both sides. You get negative 3 equals 2 divided by x plus 1. Oh, wait a second. You're adding 3, so that should be a positive 3. Almost made a mistake. Okay, because we added 3 to both sides. Now you're going to cross multiply. So you get 3x plus 3 equals 2. You're going to subtract 3 from both sides, divided by 3. X equals negative 1 divided by 3. So your x-intercept is negative 1 divided by 3, comma 0. Okay. Now for the y-intercept, that's when x equals 0. So you have y equals 2 divided by 0 plus 1 minus 3, which that's 2 minus 3, which equals negative 1. So your y-intercept would be 0, comma, negative 1. Okay, go ahead and finish up example 3. All right, let's take a look at example 4. Okay, now we know graph by direction, so that's negative 1. And again, I think I didn't put that line in correctly. Let's put it right there. Negative 1, negative 1, 1, 1. Okay. Now, here, let's move the vertex. So that means we go to the right 3. So 1, 2, 3. There's a new vertex. But here we have to divide the y direction by 2. So that's divided by 2, divided by 2. Okay. So we need to go left 1, down a half, to the right 1, up a half. Okay, now our asymptotes, we set, really we only need to worry about the x minus 3. So we set x minus 3 equal to 0. So our x equals 3 is our vertical asymptote. So 1, 2, 3. So we have a vertical asymptote at x equals 3. And there was no vertical transformation, so our y asymptote is y equals 0, or horizontal asymptote at y equals 0. Okay, then we draw our curve. You can see how, since it's at 1/2, it's very, very close to the asymptotes. Oh, almost forgot. Y equals 0. Okay, Domain is from -infinity to 3 or 3 to infinity. Range is from -infinity to 0 or 0 to infinity. Transformations, it looks like we have 2. We have a vertical compression of 1/2, and it's right 3 units. Okay. X-intercept is when f of x equals 0. So 0 equals 1 divided by 2 times x minus 3. Well, 0 times that 0. 1 times 1 is 1, so 0 does not equal 1. So there are none. Okay. Now for the y-intercept, that's when x equals 0. So y equals 1 divided by 2 parentheses 0 minus 3. Well, that becomes 1 divided by -6. So our y-intercept would be 0, -1 divided by 6. All right, if you would, go ahead and finish up example 4 and start working on your assignment, and have a wonderful Wildcat day.